Hi, in this video we continue where we left off. Sometimes we are faced with expressions that have no common factors, at least it may seem that way. In such cases, it may be worth the while to attempt what is called factor by grouping. When we factor by grouping, we apply the distributive law to various portions of the expression we are attempting to factorize. So let's illustrate this with these examples. Let's start with this first expression here. Note there is no factor that is common to all these terms here. There is a b here and a b over here, but none here nor here. There's an a here and here, but none in these two. So in a case like this, what we then do is try and factor by grouping. Note this won't always work, but in these examples it will. So we have 2a and 2b here. The common factor here is 2. So we just factorize this portion of the expression and leave this for right now. So let's put a equal sign here. And this becomes 2. And this should be easy now. And then we come over here and find the common factor over here. And of course we have w. So we take out that w. And then this becomes a plus b. So now we have an expression in which we have common factors. It might not seem so at first, but take a look at this. This entire expression here, a plus b, is a factor as it is multiplying the 2. And this entire expression, which is the same, it's a plus b, it's a factor because it's multiplying this w. So it's a factor that is common to both these expressions. As a result, I can take it out. So imagine this entire expression here, a plus b, as if it were just a number p or something like that. And then I multiply this by what? 2. Notice this times 2 gives me 2a plus b. And I multiply this by w. A plus b times w gives me w times a plus b. And so we have factorized this expression. Notice? It's now a product of two expressions instead of being the sum of 4 expressions. Okay, so let's look at this one now. In this case, I can see with these two expressions here that 2w is common to both. So I can take out that 2w. And then that becomes t minus a. Plus, and then you have t minus a. So the trick here is to realize that this t minus a, we can look at this and just simply group it. Placing these parentheses here does not affect the result of such a computation if we were to replace this with numbers. And it does help to see that now we have common factors, t minus a. And so t minus a is common, we can take that out. And we are left with 2w plus what? Remember, there's an invisible 1 multiplying this t minus a. It's 1 times t minus a. So there's a 1 here. T minus a times w gives you times 2w gives you 2w times t minus a. And of course, t minus a times 1 gives us t minus a. And we can expand this back to get this. Tw times t, tw times a, t, a. In this case, the terms are not lined up in a convenient way. For example, these two expressions here have nothing in common. Neither do these two. But I can simply arrange this and say, well, there's a PR here and there's 2R here. So let's rearrange this and write this as PR minus 2R. Of course, you could have said minus AP and then you'd have the P's in common, but this is what I decided to do. No matter how you approach it, as long as you're logically correct, you'll get the correct answer. So PR minus 2R plus 2A minus AP. So let's check PR minus 2R plus 2A minus AP. So these are the same. And then I look for common factors here, and of course I have here R, so that's R times P minus 2. That's an R. And then over here I have a common factor A, and then I'm left with 2 minus P. Now 2 minus P is the same as negative P minus 2, so I can rewrite this P minus 2 and then just put negative A and then P minus 2. In other words, I can get to here by multiplying this by negative 1 twice. Remember, negative 1 times negative 1 is 1. So if I multiply this expression by -1 twice, it has to be the same thing, even if it looks different. So now this becomes negative here, and this becomes p minus 2. And then, of course, now we have common factor p minus 2. Let's arrange this differently so you can see that you would still get the same answer. So now we go PR minus AP plus 2A minus 2R. And once again, here I see common factor P. That leaves me with R minus A. And over here I see that I have 2. A minus R. And A minus R is the same as negative R minus A. So I can come here and say. And remember, what we're doing is simply multiplying this expression by -1 twice. Multiplying this by -1, this becomes positive and this becomes negative. And multiplying this by -1 gives me -2 here. And then, of course, the common factor is R minus A. And that leaves us with the P minus 2. Okay. In this case, we have a 3 here and a 3 here. So I can simply take out 3. Some students would prefer to take out -3 and then make this minus, but I prefer it this way. So that's 3 times a minus A plus what? Plus 1. Right? Notice this times this gives us -3A. This times this gives us 3. Then over here we look for common factor, and here it's an X, and this is A minus 1. And we do the same trick here. If you don't want to do it over here, we can do it over here. So this can become a -3. Notice I've multiplied it by -1 twice. I've multiplied this product by -1 for the first time rather. And then I'm going to multiply it by -1 again by making this A minus 1. So see, I've multiplied this entire term here then by -1 twice. Which means that I've multiplied it by 1. But in a clever way, so that now it looks like this. If I just multiply it by 1 like that, then it will just stay like this, and that's not the objective. And of course, then I have the same X times A minus 1. And then A minus 1 is common, so we take out A minus 1, and we're left with -3 plus X. This doesn't look so nice to me, so I'll just rewrite this as A minus 1 times X minus 3. And so that's it for this video. I hope you got this. We'll practice more of these in class.